Hey, thanks you all for choosing this time slot over the others. I really appreciate it. If you're into orchestrating, calling many subsystems in your APIs, this talk is definitely for you. It's a real tech talk, not much mumbo jumbo, just a little setting the scene, and then we'll dive immediately into the Baker library. So, great, thank you all for having us. This is Tim Linschoten, the lead developer for Baker Library at ING Bank. Pierre Venter, the lead developer of Daily Banking Tribe. My name is Marcin Pakulnicki. I'm the head of IT of the Daily Banking Tribe, which actually means nothing else than the whole day running and fixing problems so that these guys have more time to code. Okay, so you already heard that we work at ING Bank. It's just a little to set the scene on where we use Baker and Bakery Library. We are Tribe Daily Banking. Basically, we engage in everything that has to do with opening and life cycle of all bank accounts for basically everybody owning an ING bank account. So there's basically millions of private individuals in the Netherlands and small and medium businesses. So it's everything like opening and closing of mass accounts and SME accounts, offboarding customers, offboarding by bank, by customer, but also more complex processes like a seizure on a bank account. And last but not least, mobile onboarding, immediate mobile onboarding and opening of a new account for private customers in the Netherlands through the mobile app. It's also where we use Baker and Bakery. So we have more or less 160 software developers divided into 30 teams. Right before we're going to dive into the Baker library, just a few words for you to set the scene on what the places of Bakery and complex API orchestration in our API landscape. So if we take the mobile app as an example, how do we work as an organization as ING Netherlands is actually the mobile app, the mobile banking app of the Netherlands is in itself a native app, being of course either Android or iOS, but only the real core is actually really native. So moving money from one account to the other or from one bank to the other, and also retrieving your product possession or your credit card or other information, that's actually native. All other digital flows are web-based and based on a contribution model from different departments, different tribes, such as daily banking. So for the coming slides, I think it's really important to notice that we don't have one centralized mobile team natively developing all the digital flows for opening or closing accounts. We are really distributed, work according to a distributed model where, for example, our tribe creates and adding additional account holder or opening a child account, while maybe some other tribe creates a digital flow for loans, insurances, or mortgages, or credit cards. Interesting to know, of course, the flows that are contributed are web component based, so they're opened as a web component in the mobile app. Sometimes we jumped with an older flow, we jumped with SSO, single sign-on, through the, I would say, classic web app. That's not much used anymore these days. So, so everybody says, okay, and a lot of bigger IT companies, banks, insurance companies, basically bigger IT enterprises build a banking platform or a platform. So what do they actually say when they mean when they say it for you as a software developer? So as a software developer, you just have to think one coherent front end, look and feel, but under the hood, you actually consume all these services which are scaled as a service or out of the box. So, for example, at ING, we have a as-a-service team that offers a Cassandra key space. So there's not a one tribe or a department or a team that sets this up from the ground. You actually consume as a service a Cassandra key space. Same goes for Kafka bus. You don't have your own Kafka bus. You have your own topic on a Kafka bus, which is centrally organized throughout ING. A global data lake, but also the same goes for authorization, authentication of your journey, of your digital flow. But also on the other side, on the front-end side, we have front-end base components which actually abstract away the CSS behind the web components so that all the front-end in whatever channels that you've got, so mostly it's mobile channel anyway these days, look the same and feel the same across even multiple instances of ING, which means like countries. So how do you get there as a big, large IT company such as ING? Oh, go too hard. So there's three things. And there's three things where actually Baker library comes into play, which you'll see in a minute. It's you need to enable scalability. So that is that all these calls to all these as a service subsystems needs to be done in exactly the same way and need to be reused. Secondly, most often you don't want each and every team to rewrite that code or rewrite the cut and paste snippets of these codes. So ideally, you want to remove it from your code base, from your API. And secondly, and third, last but not least, I would say, we need to do it in a standardized way. Everybody needs to do the same. So technical conference today. So I would say, as a head of IT, all software development starts with architecture. So there's some conceptual architecture drawing when on top you have, of course, your distribution your distribution layer where you typically have your front ends, your presentation, maybe also some CMS there, and also maybe some voice customer-facing GUI there. And then on the bottom, you have your deep backend fulfillment, right? Your traffic towards the payment systems, international payment systems, like international banking payment system, like in our case. And then right in the middle, you have the orchestration between all these layers. And this is exactly where we have Baker in place. So this is a really, really simplified example of just how many exactly the same calls to different subsystems or APIs you have where you develop digital flows. So when opening a child account, youth savings account, or when onboarding a new customer through the app, you most often just do the same. But the problem is at ING that we have hundreds of teams that needs to do the same, right? So you have customer eligibility. Is a customer actually eligible to open an account? Is he or she 18? We have to register the individual, maybe send an email, send a present, send an SMS, whatever. Actually, the opening of actual account and enable billing for that particular account. So remember the two slides before, quite abstract notes, but this is actually what it comes down to if you want to reach this scalability. So all the teams need to call the same subsystems in exactly the same way. And you don't want to do it in imperative or functional style, reinventing the wheel, rewriting the code. So ideally, you abstract it behind the DSL. That DSL needs to be reusable. So it needs to be stored somewhere for reuse, to be reused by other teams. And of course, it's JFL. So we do it in Java and Scala. So this is why we came up with Baker library. So in Baker, you have recipes, and the recipe is in fact a chain of events, a chain of interactions, which opens an account, adds additional account holder, and does a whole bunch of other stuff that other teams can reuse. So the recipes are made up of interactions, and interaction can typically be something like retrieving the age of a customer, retrieving I would say, a green light for the anti-money laundering check. And the interactions gather data about the customer along the way. And of course, it's a asynchronous event-based engine. And then, what about the teams that actually built the digital flows, that built the digital flows for the mobile app? So remember what I said about abstracting away the DSL logic, that you don't want to rewrite it in your API file system, in your API business logic. So what we've made is something where you write your recipe in the DSL, and you actually connect through REST to an OpenShift environment when you actually deploy your recipe in the cloud. And so you don't have the orchestration itself, the code for the orchestration itself, in your API file system. So remember the slide of the contribution model at ING that we have? So we basically have the Baker platform team, which maintains the core Baker Scala library. By the way, Baker library is totally open source and can be found on GitHub, about which in a second. And then on top of that, for the consuming teams, we have the Bakery cloud service set up, so in OpenShift, in containers, so that teams can deploy their DSL recipes there. So the team of Tim actually maintains the Azure DevOps pipelines and the reusable recipes in Git. Of course, provides support, standby, and all the other teams in our department and other departments create these interactions and reuse the interactions for often used processes in the bank, such as getting product possession, customer eligibility for an account X, or just showing the monthly fee, how much you pay for an account. So, in other words, why should another team write this logic from the startup again and again? All right, I'll be better moving out of the way because now the some code starts. All right, Tim.
Okay, so again, the slide about Baker. Baker is an open source ING-built Scala library, and it supports as well the development via the DSL as the execution of your mostly complex orchestration API. It doesn't have to be complex, but that's the main use case. Our DSL supports both Java and Scala. Most users in ING use the Java DSL because that's the most used, but we ourselves try to use the Scala. So we're quickly going to go to the metaphors. I think Marcin already told it. So you have the recipe, which is a description of your business process. The ingredient, which is a container for your data or your data itself. We'll get into details a little bit more. An interaction, so this could be a call to backend system most of the time. These are the reusable components. That's how we get reuse. And events, well, event isn't happening. It's kind of the same in every system. And finally, we have baking, which is creation of a new instance of your recipe. So that's kind of creation of a client request. So let's go into the Baker library itself. It consists of two parts, like mentioned before. It's the recipe DSL and the Baker runtime. And we'll first have a look at the recipe DSL. So that's designing your orchestration logic. And afterwards, we will go into the Baker runtime and how do we execute this orchestration logic. And for all the examples, we're going to use a very simple webshop to keep it simple. Okay, let's start with the recipe DSL. So a DSL stands for a domain-specific language. It's kind of just your own language that you design that fits your domain. In our case, we started with a baker. So eventually we had ingredients, interactions, and we also needed events. Didn't fit the analogy that well. And with these reusable components, because that's the core of it, we can create recipes. So you can create reusable interactions, ingredients, and events that you then use in a lot of multiple orchestration flows. Okay, let's quickly go a little bit deeper in each of these. So an ingredient, like I said, is just data in your model. So names, birth dates, IBAN numbers, anything, right? And these are, in the visualization, which we'll get to in a moment, are orange blobs. So in our example, we have payment information. So this is the information of the customer to do a payment. Let's quickly go into how does the code then look. Well, it's just a class, right? There's nothing special of this. This is just a class, and it can have some fields itself. But in general, ingredients are POYO. So we support all the basic types and some datetime objects. But yeah, it should be plain data. So no inheritance or whatever. Then we have an event, which is, well, yeah, happening inside or outside the model. So from the outside in, events happen, and then inside the recipe itself, also events will happen. And those are the gray diamonds. So in this example, we have an event, shipping address received, that provides the shipping address, which is the event. So events can provide ingredients. Now, let's have a look at the code of an event in the DSL. Again, just a class, nothing too special. Every field you have is seen as an ingredient it provides. So in this case, the shipping address received has a shipping address, so it will provide the ingredient shipping address. Then the final one of the reusable components, the interaction. These are the actions that need to be executed to fulfill the client promise. So these are the backend calls, opening of the account, checking the age, like we saw before. Another thing that we do in interactions is validations. For example, an age check validation. That's also done in an interaction. So it's not called to a different system, and a lot of times we call them sieves or pure functions. They're kind of pure functions. And interactions take ingredients, or they require an ingredient to execute, and they can provide events. So one of the two. So in our example, we want to reserve items for the customer, and we first need the items that he wants to have reserved. And the outcome will be either they will be reserved, or we cannot reserve them since they're not available. So you can already see a little bit of a flow diagram in the interaction itself. So let's go into the code of this interaction. So it just has the name, reserve items. It's just an interface in this case. You need to extend your interaction class, and you need to provide some annotations. So in this case, it's a little bit more than the other two. So in this case, you have fires event one-off, order at unavailable items, or items reserved. So this interaction will fire one of these events, and it will have an apply function that requires an ingredient called items, which is a list of item. As you can see, this is an interface, so no implementation has been written. So for the DSL part, you don't need to write your backend code yet to call the systems. That is needed at runtime. So if you're designing your process, you don't even need to implement anything yet. So you can make your whole flow, even against mocks, whatever, and set it up. And finally, we have a recipe. So a recipe is a combination of a list of interactions, so these are the backend calls we want to have executed, and a list of sensory events. So sensory events are events that come from the outside in. So not internally happening, but providing data into the model. So we don't mention, as you see, ingredients here. And we don't mention ordering in interactions or sensory events. So we just have two lists. In a second, we will then show that that's not needed in the Baker DSL. So let's go to the code. So this is the recipe we defined for this web shop. We have a make payment, reserve items, and want to ship the items. And the ship items has one requirement, that the payment needs to be successful. So it reads pretty straightforward. So we have the web shop recipe with the following interactions and with the following sensory events. So there are also 3 sensory events. Pretty straightforward. So then there's one more thing. We have a compiler. Well, it's written in brackets because it's not really a compiler. It doesn't take bytecode, but your DSL classes, and it will compile them into what the runtime needs, what we call a compiled recipe. Underwater, that's a Petri net. Some might know what it is. Won't go into too much detail in this presentation, but that's the mathematical model we use to determine what to execute. We also, of course, validate the correctness of the recipe. Are all interactions, do they have the required ingredients in the model? Are the events available that you require? Stuff like that. And last but not least, once it's compiled, we can visualize the recipe. So if we take the recipe we have here, we throw it into the compiler and visualize it, we get this. So this reads mostly like a flow diagram. So from the top, we have the order placed, which will provide items, which the reserve items need. And then you can, if the items are reserved, the make payment need to reserve items, but also the payment information. So it's pretty straightforward in how you read it. And this also helps you during development. So if you have a very complex one, it can really be helpful. Of course, this is as simple as possible example. Okay, so far the DSL. So we have a compiled recipe now, but now we want to execute what we just built, right? And having a nice diagram doesn't help you on production. So the Baker runtime takes this compiled recipe, and at least in Baker, it is run as part of a AVM. We will go into Bakery afterwards, where it's separated, but it's just running inside of your own JVM. And it uses akka and actor model, and it, if configured, can use event sourcing towards Cassandra, so we never lose the state of a process. So if your node goes down, it will just continue where it left off because it's all persisted. So the first thing we need to do, we need to set up a baker, and you need to do 3 steps. Well, the first one is create implementations for interactions. You see it on the right. In this case, I won't show the code what really the instances do. That's of course written by you yourself, but you just make a list of those. Then you set up the baker itself. So you give that some akka things, the config file, you give it an actor system you are in yourself control of, and you give the list of implementations. And then a baker is started. And depending on the configuration, it can be a cluster of multiple nodes or not. That's all up to akka. And finally, of course, we need to add the recipe. And we just add the compiled recipe we had from the recipe compiler. Well, some of you will also see the .get at the end. The whole baker runtime returns completable futures, so you can write asynchronous code against it. But for example, I'm just going to block everything. So .get is just blocking until I get my result to keep it simple. Okay, so now we have set up the baker runtime. How do we use it? So it will be 3 steps. First, we'll bake a new client request. So that's just creating a new client request. Then we'll fire sensor events into baker. And finally, we get the state out of baker. So we never say execute an interaction, because depending on what data and events are available, the baker runtime will execute it for you. So first, we create a client request. At the start, you need a unique identifier. We advise UUIDs. It's not limited to UUIDs. If you have some other IDs that is linked to your process, you can also use it. And then you just bake it, and you do that by saying, hey, this is my compiled recipe, the ID of that one, and this is the new ID we want. And of course, again, .get to block it. So now a process has been baked. It doesn't do anything because it's just an empty process at the moment. So the next thing is we need to fire events into the baker runtime. So these are happenings outside of the model. Most of the time, this is an API call on you, or maybe on the front end, someone has clicked. The client has clicked something. So the first thing is we create an event instance for the order placed with the items you want to have reserved. I'll show you in the demo this. And then we fire the event into the model. And it's a mouthful. Fire event and resolve are completed. It's just firing this event and completing the future when all the execution is done. You have some options, but for now that's not too important. So this just gives the event to baker. And depending on your recipe, it will now start executing your recipe in the background. Yes. And finally, if you have built your API, you probably need to give something back in your response, so you can get the information outside of out of baker, the baker runtime, to just get the recipe instance state for your recipe instance ID. You can get the events and ingredients, so that's all the data and all the happenings, and you can determine your API return code and your body depending on this. Maybe good to mention, the fire and resolve and completed also returns in the completable future all events and ingredients that happen. So if you write it correctly, you don't have to really do the gets themselves. So this was a quick view of how you use Baker, the library. Some things that happen on the background for you. So we've automatic retry of technical failures of interactions. So Baker executes the interactions depending on what's available in your model. If this then technically fails, in your recipe you can configure what you want to happen. And for technical failures, which are any runtime exception, we can retry it for you, so just on the background. And this will happen if API returns 500, you throw a runtime exception, Baker sees, okay, what should I do? In this case, we'll just try again in 10 milliseconds, or there are multiple configurations. So it automatically has some technical retries in it. It will automatically do parallel execution of paths, call multiple backend system at the same time if possible, if the data is available. And if configured with the Cassandra, it will automatically persist your state after each interaction and event. So yeah, these are some nice things coming out of the box, mostly because we use akka. Then we'll go a little bit into Bakery and view of it from one of the feature teams using Bakery. Okay, yeah.
Thanks, Tim. It was super chilled. So it looks like you do this quite often. Cool. So I am going to tell you a little bit about the part on the right. So Tim and Marcin spoke about the left, but me as a consuming team, I am more like on the right side, right? So where we basically consume baker and bakery in my situation. So which brings me to the demo. So I'm going to exit here. So what I've got in the demo here is a couple of things. The first thing is Postman. We all love Postman, don't we? The second thing is I have a browser here running something which allows us to visualize our recipe. I will come back to this one, and then of course I've got a command line. So the first thing that I just want to do is, okay, so what we have is of course the web shop that you folks can also check out. It's the open source project. So this is a typical web shop that you can just run locally. So if I do a cube ctl get pods, we have a couple of pods running. So I've got there a Cassandra pod running for the state. The client application itself, so that's going to be the web shop. The interactions as well. So this is bakery basically. So we've got a specific pod for the interactions as well with Kafka. And then bakery as well. So bakery is this pod at the bottom here. So that's up and running. If I go back to the browser, also I can see here what recipes do I have. Okay, cool. I've got this recipe. It's been created this morning, and it's validated as well. So the fact that it's validated means that the interactions are there. They are ready to use. Everything is cool. I can look at the interactions as well. So part of this product shop, of course, we have a make payment interaction. So these are basically, well, this is a way to basically see what sort of inputs I have. It's a little bit small, but that's basically just your payload. And also what it produces. Same goes for reserving my items and the shipment items, whatnot. So I can start doing stuff. So the first thing that I want to do is just create an order. Oh, before I do that, actually, I want to go back and look at the instances. Recipe, where was that again? This bad boy, right? So this shows me exactly what Tim just showed earlier. This is the current configured recipe in its original state, so I've not done anything yet. I would expect something to happen when I create an order. Right, so I got an order back. I'm just going to copy this recipe instance ID over here. Go to my instances, just paste that bad boy in and hope it works. Okay, there we go. So now I get to see that, okay, there's something happened, right? So the first thing is some event. So that little diamond means the event occurred, which is placing the order. And it also contains, of course, the ingredient, which is the order itself. And it was then executed as an interaction. So that's pretty cool. Of course, I can do the next one. You would assume that the recipe would be updated. Let's hope so, if I refresh it. Okay, there we go. So now I've provided my shipping address as well. So you would imagine if I, place the final order that this will be executed, which it should. But actually, what I want to also focus on a little bit more is what Tim spoke about, which is the resiliency, of course, of having our events and the Akka event sourcing and such. So let's just kill one of these pods. So kubectl. Delete pod, and I am going to kill maker. Oh, I've got that wrong. I missed an E. Ding, 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 ding. Okay, so of course this is Kubernetes, so it will try and start this up again. So if I refresh this should be down. And while we are waiting for that to start up again, get pods. So there's nothing running yet. The demo effect will not kick in, I promise. I'm sure this will work. Okay, cool. Going back to my instances, paste this back. Recipe. Oh. Uh-oh.
Let's try again.
Let's just do this. And go back to this one. Copy that back. can also try this. I would assume.
No, you need to go to instances.
Instances. Paste. There we go. Cool. Oppa.
Nerve-wracking.
Excellent. So basically what happened is that, with Akka and Cassandra and event source, we basically got back our state. So this means that if I go back to the last interaction, which is to make the payment, that this should be then completed. So this little simple thing actually saved us so much pain as a team. We have some process that calls like 34 APIs, and you can imagine if something goes down somewhere down the line, people had to, at stages, do stuff by hand to go and try and figure out what the hell's going on. So on the flip side now, what we have is, you go to the office in the morning, it's like, hey, something went down, but hey, it solved itself. So that actually made life for me as a developer way, way better. So I'm going to go back to just basically telling you what Bakery is. So Tim spoke about Baker. And Bakery is an alternative way to basically run the Baker runtime, but not in my own local JVM. This is now running externally, and it's being called basically via HTTPS. This also isolates the clients from the complexities of running the Bakery runtime. So it basically means that me as a fellow team member do not really need to know Akka or Cassandra to the extent that I sometimes have to when I use Baker. I can use this actually. Now this is a typical implementation of Bakery at ING. So basically we run Bakery in ING in several isolated instances, and each instance serves one or more client applications. So this box at the top over here, that one represents one such client application. Additionally, Bakery is also, each instance of Bakery is independently configured with its own recipes, interactions. So that's not in my code anymore, it's now been configured in the cluster basically. So that's the main difference that I, as a team, basically see by using Bakery. Now, because of the fact that we consume its functionalities as HTTPS, we of course also have an API definition for Bakery, for the as it runs in the cluster. So the interface that Tim spoke about earlier, like baking the recipe and creating the interactions and all of these things, are now exposed as HTTP endpoints in the cloud. And I do not have to do the heavy lifting of defining all the code. It's not really heavy lifting, but defining all the code that he showed, I do not have to do that anymore. I just consume some endpoints. So it makes it just easier for me. And this is the client. This is the only thing that I need now. So if I want to run Bakery myself, I still have a Baker, but it is just way simpler now. Instead of defining the interaction and all of these things, I just do this one-liner, and that's all I need. Of course, we are also interested in the process, the system that we have with Baker. So each event or recipe interaction also has events that we can monitor. So we can see basically the health of our process. I can also see how many IDs were scanned as people on board, how many people were onboarded as well. So that is quite nice. And then finally, the advantages for me in the Bakery realm is we now have a dedicated squad, like the one of them, who basically focus on the upgrade, maintenance of Bakery or Baker that we run in the cloud, basically. They also have better focus to, let's say, improve the metrics around Bakery, the dashboarding, events, monitoring and alerting, as an example. And for me as a consumer, I do not need to know the intricacies, the difficulties that surround Akka, basically. I do need to, maybe take a bit of water here. So that makes life easier for me, as well as, of course, the Cassandra part. You know, sometimes you might end up with, things where you have, in some cases, a split brain type of situation with account Cassandra, and we as a team sometimes had to deal with that. But now, that's a non-issue for me. And that's actually it. So, Marcin, do your thing.
Yeah. Okay, thanks very much, everybody. Well, that rounds up the technical run-through. First of all, we always get a question, is this live? And is this used in production? Yes, this is used in production in tens of digital flows in and around ING Netherlands, Belgium, other countries as well, Spain, I believe.
Almost.
Yeah, so, so the Baker library is open source, out there, also used by other companies within the Netherlands, by the way, not just ING. Bakery platform is quite new. I think it's been built, just about a year ago, mostly used within our department and a couple of other departments within ING Netherlands. But it's definitely live, and if you use the mobile banking app of ING, there's almost if you open an account or close an account or do some other service for within ING, so chances are that you use Baker and Bakery Library. Other questions that you guys might have for us, or yeah, go ahead.
So if you want to use it in your own company, for instance, then you need to make implementation of APIs yourself to run actually in the runtime, and create POJOs to be used in the library. Is that right?
Yeah, so take it.
I'm not entitled to answer that. I'm not the lead developer of the platforms.
I will.
Just an IT manager.
So yeah, so the code to call your backend, so the implementation of interactions, you still need to build, or someone in your organization needs to have it built. So that's one of the, you need to, in our case, we have a very big project with all the implementations and interactions that are shared. So hopefully someone build it, but if it's not available, you still need to build it. And ingredients are indeed just POJOs, and it is advised to set up a common domain for this, right? A common ingredient model to reuse in all your recipes so the interactions are compatible.
So basically, as a consuming team, we would, as an example, we had to build something new and an interaction to an API that does not exist yet. And once we've built it, we then contribute it to the catalog, which we call it, which then means that somebody else can just, consume that same interaction. Then have to build it again.
Question: how easy is it to change existing workflows in runtime?
So existing workflows do not get changed. So we've checked this at the start of when we built Baker, and we decided that much smarter people have failed in making this, so we will just not support it. So the moment you bake your recipe, that's the flow, that flow for the client will take, right? So you can change your implementations of the interactions. So it could do maybe if it's in the implementation itself, but you cannot change the recipe. So to have fixes, you will need to have a new instance baked of another recipe. And Baker supports running many recipes at the same time. So there's also not really versioning per se, it's just new recipes. Because especially with the Petronet, it's very hard to modify and ensure that it works, and we decided not to support it.
Is there a sort of a process management system in general? Is there a sort of way to, you mentioned retries, etc. Is there a way to handle still processes?
Not directly in Baker, but as we saw with the Kibana dashboard, we expose all the events as default logging, so you can easily check, even automated with alerting, if your started process are the same as your finished process, because you just count events. So that's what we personally do. We just have a start and end, and if that start and end is the same, then, well, something is going wrong. So that's how we do it.
Yeah, go ahead.
How does this relate to concepts we already know, like workflows, business processes? Is it really new?
Yeah, I think it's new in the way that it helps us scale reusability towards the banking platform itself. What it also helps us a lot, I would say, is a side effect, is that the visualization of the process for us as a financial organization tremendously helps us with evidence in audits, all kind of evidencing towards regulatory bodies. We didn't think about that before, But yeah, is it new? I don't know. To be honest.
There are other platforms that do the same thing, but what we wanted was to have everything running in our own API, because our APIs need to do the orchestration. Because in the past we used different frameworks for orchestration, but we're now in a microservice world. Everything should be REST APIs, and everything, preferably in ING, should be on the AVM, so we don't have to pay very exorbitant license costs. So in that sense, it was new when we built it. Of course, there are many platforms that also do orchestration and have similar features, but not in the AVM, not as open source, not in your own API, as far as we know.
Another question. Go ahead.
How is security handled? Can everybody just enter new recipes, or is there like authorization level?
That depends on Baker and Bakery. With Baker, it runs in your AVM, and it's a function call. So you need to ensure that the function call is only called by code that has been authorized, of course. In Bakery, that depends on your setup. So in our setup, we use the ING standard authorization authentication for our endpoints. So there's an add recipe endpoint, as you imagine, and that's, of course, only authorized by an API that is we are running the orchestration logic for. Right, and we run a separate cluster per consumer. So it's not one big as Baker runtime, it's many small ones to ensure that data is also not together. So yeah, it's mostly just how you do any REST endpoint authorization authentication.
Yeah, we basically just subscribe, you know, so I subscribe my API to consume yours and you approve it, and if that only when that's done with peer tokens and certificates, of course, it's then allowed.
Yep, go ahead.
And you would write the recipe in the app itself?
Good question.
That really depends on more of the organization and the flow, right? Because you do need to dedicate a team to run a bakery cluster, have a setup, and have it all. So if you're writing your first one, you should probably run it in Baker because you will be the first one to try it out. And if you run Baker, you also have the choice to run the in-memory implementation. So that doesn't have all the nice features of the akka implementation, but then it's more straight-through processing, so you still have the DSL and execution. And if you need to set up the akka cluster yourself, if you have the persons in your team, you can do it. If Bakery is available for your complex orchestration and you need state, because that's a very big process, packets can be down for multiple hours and you still need to finish it, then I would definitely see if Bakery is available for you and then use it. So most of our new processes go to Bakery, and only if they're stateless and very simple, they use Baker in-memory version.
Yeah, so maybe if I were you, I would, correct me if I'm wrong here, but I would go with a stateless implementation of Baker myself first. Just because you don't have to deal with, you know, the whole Cassandra and all those sort of things. But of course, you have to determine for yourself whether you really are stateless or not. Because one example, for instance, is when you have, let's say, an API which you have multiple endpoints on, and we had such an example as, for instance, where the first endpoint gets called to initiate some process, the second endpoint on the same API gets called to confirm that I want to do something, and the third one does the actual submission. And although I do not have to save anything in a database or whatever, or I'm not worried about if something goes down, the user can just restart the process, still I needed to have a state full implementation there, because if I run my API in multiple data centers, I might call the first endpoint on the one pod in data center 1 and the second endpoint on the second pod in data center 2, which will not know about one another. So I needed to have like actually a state there. So those things you do have to consider if you want to look at it that way.
So then following up, what percentage of apps use actually Bakery and within ING, I mean?
Not that many, I would say, actually. But again, it's not because the fact that it is not worth using it. It's more because of the fact that people just don't necessarily always realize that, hey, you know, there's that thing out there. Of course, you also have resistance to change sometimes, you know, and of course there's new tech there that not everybody's like always super keen to go and do it. But most of our processes are fine with being eventually consistent. So actually, you can actually implement it a lot more, I would say, than what we have.
Yeah, this just exists just a couple of years, first of all, and second of all, if you have a simple backend before frontend, like an experience API, a simple experience, you should not use Baker. You know, you should just write the code. That's it. But in all the other, I would say, critical processes, with I believe that our offboarding API, like basically closed by bank or closed by customer, just calls 30 plus other subsystems. You just can't write that code, or just write out. I mean, it's just too much work.
You have to go with Baker with that.
Yeah. Right.
So
Maybe 2 questions. Okay, 1 question.
yeah, I think follow up of this question. Say that you have a Baker API from the past, and you thought it would be stateless and didn't need to preserve anything, but in the end you think, hey, maybe I want to preserve state for 2 weeks so customers can see the flow. How hard is it to switch to Baker?
Yeah, I think I can answer that.
Yep.
We try to make it as simple as possible because most of our consumers were stateful applications that existed before Bakery was there. We just had them running Baker themselves. So as we just shown with the client, your API code itself is almost the same. You just initialize a different type of Baker. Your interactions are the same, your recipe code is the same. So the only thing that is different is where your interactions run, and there are multiple options. It can still run on your site, and then Bakery will call your interaction to execute, or it runs in the cluster. So that's a little bit of work, and of course a cluster needs to be set up. But from your coding perspective, it's all, let's say, structured differently instead of rewriting for Baker and Bakery.
Okay. You have time for 1 more question? Yeah.
What happens in your flow if you call the webshop example where you get order? What happens if you didn't make the first call a second time? Can you make a distinction between the first time you get an order and the second time you get an order? Or will it always say, no, I'm now in the state of payment and shipping and it needs to go forward?
Well, you shouldn't model it to be allowed to fire multiple times. So by default, sensory events can only be fired once into a recipe. You can override it if you think, well, I need it 2 or 3 times. You cannot really see the difference in that case. So the only cases where we have had that is some counter mechanism or some even loops that we needed to build for very complex things.
It's quite common to make multiple orders in the same session, right? So
It's to add it to an order. So what we do in that case is you have 1 ingredient that's just the order you want to add, then a sieve that takes that and the currently existing ones and outputs the combined one, and then it can loop over that. And every time we'll just add and grow your order. And at the end, when you say, okay, now I'm gonna place the order, you take that plus event and execute it. So you need to do some smart modeling in that case, but we do stuff like that a lot. Yeah.
Okay, I would say we end it here. Thanks for coming. Thanks for choosing our presentation. Thank you.